Okay, good morning. So let us continue with this lesson. I think we will be able to finish this today. And now one more thing is left, and that is about the lines. So let me start with an example. And this is an important one, okay? I give you a point, and I give you a plane, then I ask you find the distance from the point to the plane. So what do you think we can do in general? So I would say that let me write it in this way. Determine the distance from the point distance of the point is probably better, yes. For example, let me call it A with coordinates 2, -3, and -5 to the plane let me call it capital P, and I give you its equation. 2x is equal to -z plus 14. Okay, so that's a important example. So, and then we can of course find the formula for this in general. But before doing that, first of all, we need to understand what do we mean by the distance of a point to the plane. What's the meaning? Because the distance from a point to a point is clear, but the distance from a point to a line and a distance from a point to a plane, yes?
The shortest distance from the point,
which means
a perpendicular
line. Yeah? So this means that, for example, if you want to understand what is going on, let us assume that this is our plane. So let me call it plane P, and then this point, if you're so lucky, if it lies on the plane, then the answer to this question will be 0. Yes. But how do you know that if this is the case? Do you think that this point lies on this plane? Yes or no?
No.
No, because if it is supposed to be on the plane, the coordinates should satisfy the equation, but it does not. Yes, 2 times 2 times x is 4. On the right hand side, I will have 19. They are not the same, so this is somewhere else. Okay? And now, as Kevin defined, we want to. So let us consider that this is A, and then the point is to draw this perpendicular line somewhere. Yes. And then we want to find this distance, so let me call it h. So the question is that if I give you in general the coordinates of the point and the equation for the plane, how can you find this distance? Because in principle, whatever you can do in reality, you should be able to also calculate using mathematics. Yeah? So if I give you this plane, and then I give you this point, it's not a very hard thing to actually calculate the distance, yes? Of course, you need to have this plumb line, if that's horizontal, so that you know the exact vertical direction, and then you measure this distance. Now, if you want to do the calculation, how do you do that? Do you have any suggestions? Yes?
Maybe we can use the normal vector and then extend it to A.
No, the point is that we don't know anything about the normal vector. We can read the coordinates of one normal vector, but because we do not have any pictures in our hand, we don't know what is the. What we know is that that is exactly perpendicular to this plane, but how long it is, how short it is, in which direction it is pointing, we don't know, and it is not that easy to realize, yes, unless you start drawing a very precise picture. Of course, normal vector will play the role, because whenever in this lesson we learn, whenever you have a plane, you should imagine there is somewhere a normal vector to the plane as well, yes? And of course, if I ask you, can you read the components of one of those normal vectors. Do you remember from the previous lesson, you have to move this to the other side. For example, minus 14 equals to 0. Then normal vector, one of the possible normal vectors is what? 2, 0, and 1. Do you remember the coefficients of x minus z? Of course, for understanding, I draw a normal vector here, but I really don't know. First of all, there is no location associated with my vector, so I cannot say that this vector starts here, ends here, or it starts here, ends there. We don't know because there is no location associated with the vector. And also we don't know the length. I don't know. You need to have this picture is probably not very good, but so let me just draw one normal vector. Your reasoning should be independent of the length and the direction. Of course, in this case, I put the tip of the arrow here just accidentally. It might be that it's the other way around. We don't know. Yes? But anyway, that's better than nothing. But that's also a perpendicular vector. Okay, so then how can I use this to calculate this distance? Or any other way. I'm not forcing you to use the normal vector any way that you might think it would be better to do. Okay, I pause recording so if you can think. Yes?
I'm not sure exactly how to do that, but if you place the normal vector on the point A, so it transposes, that what it's called?
Parallel transport.
Yeah, transport. And then you create the equation for the straight line that goes through that vector.
We don't know how, do we? It's line is space. Unless you know, of course that is possible, but we haven't studied that yet.
Okay.
Finding an equation of a line in a space is different from finding an equation of a line in a plane.
Oh.
Yes, because in the plane we have something called the k-value, which is measuring the slope. But the notion of a slope doesn't make sense when you go to a space. Yes, giving you the angle between a line and the x-axis will not actually make the direction of the line fixed, because then you can go, for example, like a cone around the line. So then that's the hard part. This is why I started to teach you planes first and then lines, because the algebra for lines is a little bit harder. But usually the logical order is probably start with a line and then go to a plane. Now that is working, but not right now.
Yeah.
That's my point. So you have to use vectors quite good. So this lesson is actually a good experiment for how much you learned about vectors. So the vectors that we learn are very powerful, the operations for vectors we learn. So we have to use them somehow. How? The point, let me explain it here if I can demonstrate it here. So I would say that I pick a random point here. This random point is easy, yes? There are infinitely many points. You pick a random point here, and I call it B. Then this point is a random point, and that point is a point is given to me. Then I can construct this vector. Okay. Now can you tell me what to do now? I heard about projection, so that's correct. So projection of what onto what? That needs a little bit of demonstration if I can show, because this random point that I choose, so you can also imagine parallel transport. Instead of putting it on top of that, as you said, we can parallel transport and put it, imagine it on my random point. Yes? So instead of imagining this vector from here, when I chose my random point, it is B, I can parallel transport it in my head and put it here. Yes? So that is also N. But then, so you need to be able to convince you, this H is what? If I project this vector onto N and measure the length of that projection, it becomes exactly the height H. Is that understandable? So for example, I don't know how can I demonstrate it here. So for example, assume that this is point A, I'm trying to measure this length. I chose a random point here somewhere, I don't know where, because that's random. But then I take that point and connect it here, it's too short. Yes. Anyway, so I have this, I can change the, okay, so this is my point, I want to measure this one, I pick a random point and connect it here, yes? Something like this. And then the normal vector is also somewhere here. I don't know, is it long, short, in which direction it is, but I know it's perpendicular. And now do you see that if I project it here, this length is equal exactly to this length. This picture is not very good, but here in the demonstration I think it's very, very clear. Is it? Okay, so that's it. So what you need to do is to find a random point here. So this method you need to learn. Okay? And then of course we can do it once for all, get a formula. But that formula is not that useful if you don't understand what is going on. Okay, so what we do, first of all, let us understand this random point. So can you tell me a random point on P? How do you choose a random point on P?
You can just put in like 1 for each, like for X and Z.
Not for X and Z.
And then
That's not under your control.
I mean, you need to make the equation work.
Yes, for any choices of X and Y that not, so you cannot say that I put X and Z equal to 1 because it might not work. Here I have only 2 variables, so I choose one of them, whatever I like. The second one I have to calculate, that's not under my control anymore, yes? And I agree with, I don't know, do you agree with me, might be 0 is a good choice for Z. Yes, I don't know, that's up to you. I choose 0 for Z. What happens for X? X becomes
7.
What do you choose for Y? Because you have to choose, that's a random point.
Also 0.
Yes, anything that you want, probably 0 is the best. Because there is no constraint on Y. So you can choose whatever you like. So that is a random point. If you don't believe, you can check it. You have to replace X with 7, replace Y with 0, which you don't have, and replace Z with 0, and then you see that this will work. So that's a random point on the plane. And then what I do, I want to find B vector BA. Now tell me, this is a standard, and this is, by the way, here you should be very quick in these things. So this is a point, that's also a point, but from these 2 points, I want to construct a vector with initial point B, final point A. What should I do? You should have to be very quick here. Yes?
A minus B.
The final point minus the initial point. So it becomes what? A, which is this one, minus B, which is minus 5, is minus 3, minus 0, and then minus 5, minus 2. Yes? So this is BA. Then if you have forgotten, then I can tell you. So the projection of any vector, so let me write the formula here for you. The vector U on vector V, we had this before, so this is U dot V divided by norm of V squared multiplied by V itself. Yes? So that is the formula for the projection vector. Now here, you understand that the height is the norm of the projection of vector BA on vector n, the normal vector. If I calculate this, according to this formula, BA is playing the role of U, N is playing the role of B, so this becomes BA dot N divided by norm of N squared multiplied by N. But everything you can calculate. If I ask you what's the norm of N squared, it becomes 2 to the power of 2 plus 0 to power 2 plus 1 to power 2. I don't need a square root because there is a power of 2 here. And BA dot N, we know how to calculate. This is BA, this is N. I have to multiply the first number by the first number, multiply the second number by the second number, the third, and then add them up, yes? And then I have N in front, which is this one. Yes? And then what happens? So this is minus 15 divided by 5, which is minus 3, and I multiply it there. So this becomes minus 6, 0, and minus 3. Agree? Am I allowed to divide by 3 here?
Yes.
Yes or no?
No, because we want the length.
Here we are caring about the length. So you shouldn't do that. So you need to understand when you are allowed to do. Because if I divide, I am making the projection shorter. But I'm not allowed because I want to actually calculate the height. So here the height is nothing except the norm of this projection. So the norm of the projection BA onto N. And then this becomes square root of 36, 0 and 9, which is 45. But 45 is 9 times 5, so it becomes 3 times 5 length unit. So that is the distance from that point to the plane. Yes? Yeah.
So the length of N doesn't matter for the projection.
No. That's good. If you want, you can change the point as well. The numbers involved become different, but the final answer should be independent of what point I choose, because we understand that this should be the case. If you don't believe, you can check it out. And then you see that that's exactly what is important. So here, can I, for example, divide by 2 and continue my calculation here? Here I can, because if I divide, what I'm doing, I'm changing the length of N. I am not affecting the length of the projection. Because if I have this vector, and I have this vector, if I tell you project this vector on this vector, so you extend it, and then you just say that this is the projection. And if this vector is here, if I ask you to project it, you will do the same thing. So the length of that vector doesn't matter, but this is important. You are not allowed to divide by 3 or something. Is that clear? Okay, but let us do this once algebraically, okay? So if I give you a point, there is a nice relation going on actually. So if there is a point with coordinates x node, y node, and z node, and we have a plane of equation ax plus by plus cz plus d equals to 0. Do you remember? In general, an equation of a plane is of this form. Every plane that you can imagine has an equation of this form. Now I ask you, what is h? We want to do it algebraically. Okay. But the idea is the same. So we want to discover a formula. That's also good to do. This is algebra. But the idea is completely the same. So what was the first step? The first step is to choose a random point on my plane. Yes? Okay, so do you have any suggestions for your random point? Yeah, it shouldn't be very... I don't think there is a best random point here. Is there any best random point? Of course, if you are lucky and this random point ends up here, that's the best one. But there is no guarantee that we can do that, yes? the way, before solving that problem, could you also find this point? Of course, according to what Ruben said, we will be able to do this later. But right now, I think we have enough tool in our hand to be able to find this best point here. So how can I find the coordinates of that point? Do you want to think? I can pause the video. Any ideas? Your idea was correct, I think.
If you choose the correct point, then the new vector that you create, BA, would be parallel to the normal vector.
Your strategy is correct, but how you can implement this strategy in real life?
Maybe by doing the cross product. No.
No, but just give me a step-by-step, instructions a step-by-step. What would be the first step?
I can't give you more than that.
Okay. So Ruben, do you have any idea how practically do this?
BA plus the normal vector times the length of or times h.
BA plus?
Plus the normal vector times h, but then you would have to choose the right.
No, but a strategy that Kevin described is correct. But can you tell me how to do it step by step? Because he said that, it's correct. Because you see that when I choose a random point, what is the probability that by choice, just by random choice, I get exactly this point 0? Yes? But we want to fine-tune, so we want to find a way that we can find exactly this point. Because if I can find this exact point, there's also another way to calculate this height. Yes? I can find the distance between them. That's it. Yes? So how can I find that one? So you said that if we have the right choice for B, then from B to A, it becomes parallel to N. This, by the way, at this level, this shouldn't be hard for you to tell me what to do. So you want to find this B, the way that you have to think. So it means that how many question marks we are facing. Let me change the name. Don't get confused. So we see how many question marks are involved. 3 question marks. But question mark is not a good idea. Then let us write alpha, beta, and gamma. Yes? So it means that I have to answer 3 question marks. Alpha, beta, and gamma. Okay, but as you told me, alpha, beta, and gamma, and then if you make this vector, so what is the vector? I don't know, CA or AC, for example. It becomes, let me write AC. It doesn't matter, of course. Vector AC is this vector. Yes. This becomes the final point minus the initial point. So it becomes alpha minus 2, and then you have beta plus 3, and then you have gamma plus 5. Agree? This is your AC. Okay. Okay, then what? As you said, this should be parallel to this vector. Okay, but don't continue. How many pieces of information it will give you? How many unknowns you have so far? 3, alpha, beta, and gamma. But if you say that this vector is parallel to this vector, how many pieces of information this provides for you?
3.
No.
No, it doesn't.
No. It provides 2.
Because of 0.
No, because we can check. We can see. Okay, how can I use this fact that AC is parallel to N? What should I write? We know that AC is parallel to N. Then what can you conclude? You can conclude, for example, the cross product is 0. Yes? So you can conclude that the cross product is the zero vector. Yes? But let us check now. What is AC is this one? AC is alpha minus 2, beta plus 3, gamma plus 5. And what is your N? N is 2, 0, and 1. Yes? This is supposed to be 0. Do you remember how do we cross product? So I cover this one, I multiply this by that, minus this by that. This is beta plus 3. The middle one the same, but there's an extra minus sign if you remember. So I put a minus sign. This multiplied by that, minus this multiplied by that. Yes? And then what do I have here? This one, 0, that one is minus. Okay, is that understandable?
Yes.
Yeah. Okay, but then you see that this is not 3 pieces of information. This is just 2 pieces. I could predict that, you know, because this one is 0, that one is the same equation. It doesn't give you a new equation. Yes? So you see, this is, let me simplify that. Okay, so let me simplify that. What happens? I have alpha multiplied by negative signs minus alpha. And then I have minus 2, minus 10, minus 12 multiplied by that is positive 12. And then finally I will have minus 2 gamma, which becomes positive 2 gamma. And then what happens? The other one is minus 2 beta plus 3. This is the cross product. Agree with me or not? Yes? So that's the cross product. But as you mentioned, they have to be parallel if this is the right choice. So this means that this vector should be the 0 vector. So this means that the components should be 0. All of them. So let me just write it here for you. This means that I have beta plus 3 equals to 0. I have minus alpha plus 2 gamma plus 12 is equal to 0. And then I will have 2 minus 2 times beta plus 3 is equal to 0. But apparently they are 3 equations, but they are in principle 2 equations, yes? Because the first equation gives me beta is equal to minus 3. This third equation also gives me the same thing, so that's not a new piece of information. Okay, I was able to answer one of my question marks, but unfortunately there are 2 more unknowns left. Okay, and then this means that I have to find a way to solve that. So what is your suggestion? And by the way, I want you to think more or less much better, Joe, because you are doing mathematics as specialization. On the other hand, you know that there is nothing wrong with your solution. If there is nothing wrong with your solution, it should work. So you shouldn't doubt, okay, so this method is wrong. No. Because you see the method should work. So the algebra should also follow you. Okay?
Could you set up another system with that and then also the equation of the plane with where the coordinate satisfies?
Exactly. That's what you are ignoring. Yes? So this point is not, because you see, whatever I have written here is also true if this point is here. Yes? Because this one is still parallel to that one. If this point is also here, this method will work. Now that is clear that I shouldn't be able to fix the point. Because there are not one point, there are infinitely many points satisfying this property. It's very clear from geometry. If it was something else, then you should be surprised. Yes? Now you shouldn't be surprised. So it means that the next one we want to demand that this point is on the plane. So it means that the coordinates of the point alpha, beta, and gamma should satisfy the equation of the plane. Yes? So what are the equations of the plane? What is the equation of the plane is this one. So instead of x, I put alpha. Instead of z, I put gamma. Plus 14. This is another equation. And then you see there are 2 unknowns, 2 equations. That's why I'm done. So it means that I can, for example, I don't know, you can divide by 2 this one. Usually I hate fractions, but let us leave with that here. Minus alpha is equal to minus 2 gamma minus 12. And if I add them together, this becomes 0, and this becomes minus 5 gamma over 2 minus 5. So what is gamma? Gamma is minus 2. Yes? And gamma is minus 2, you put it here, alpha becomes what? 8. And then finally your point is what? Alpha is 8, if I have done my calculations right. What was beta? Beta was minus 3, and what is gamma? Is minus 2. So then we were able to find finally this point. Yes? And now let us double check. So what is this length? So let us just use the distance formula. You can find AC and find the norm. But we also have the distance formula. Unfortunately, I erased A. What was A? Do you remember? A was what? 2 minus 3 and minus 5, yes?
Yes.
Okay. And then if I use the distance formula, so H becomes the square root of the difference between these two, 6 squared, 64. The difference between these is 0. So that's wrong, yes? So why? The difference between this is 9. Ah, no, sorry. The difference between them
36.
is 36. That's correct. So it's becomes square root of 45. So you see this is also working. So I want you to understand, this is a very good place to understand these things from a geometrical point of view. Okay, but let us go back to this problem. Let us try to find a formula, not just for this point and that plane, but for any point and any plane. That is the same idea. There is nothing interesting here except if you are interested in algebra and making formulas more beautiful, yes? So how can we do that? Let us do this once for all. Okay, so can you tell me what to do? What is the first step? I don't know which method you want to choose. I think the first method was better. Yes, it was a little bit harder if you want to do all these things algebraically with letters rather than numbers. So what do you think? The first thing is to take a random point on your plane. So I don't know, do you have any good suggestions for my random point? You shouldn't be very sensitive. In principle, every random point will work, yes? But because we are doing it algebraically, we still don't know. Might be A, B, or C. Some of them are 0, yes? We don't know. But except for that, we can choose any random point we want to. For example, if I choose Y0 and Z0, for example, if I choose 0 and 0, what will be A? What will be X? I put 0 here, I move D to the other side and then divide by A. And then it becomes minus dA. So the only thing that I have to be careful, this is a random point if A is not 0. Otherwise, I will put the other two 0. Otherwise, I will put the other two 0. But this is not possible that A, B, and C are all 0 because A, B, and C can be simultaneously 0. At least one of them is not 0. Let us assume that A is not 0. Okay? Of course, you can repeat this process if assuming B is not 0. So it's assuming that A is not 0, this is my random point. Agreed? And then what I do, I take B, A. So which one we did here? We did BA or AB? Do you remember BA? So we do BA is here as well. So what is BA? The final point minus the initial point. So it becomes X node plus D over A, Y node and Z node. Okay, what is the normal vector? So what is the normal vector? A normal vector. A normal vector is A, B, and C. Yes? And what I do, I project the vector BA onto vector N. So what is the answer? So the formula is BA dot N divided by norm of N squared times N. And it becomes BA dot N. So this is BA, and I multiply it by A.
the first one multiplied by A, it becomes AX node plus D. And then B times Y node, and then plus C times Z node. This is BA dot N. Yes? And then divided, oh sorry, there is norm of N squared. I forgot to put this. So what's the norm of N squared? This is simple. A squared plus B squared plus C squared. I don't put the square root sign because it is cancelled by this power of 2. And then I have A, B, and C. Yes? But I want to calculate the norm of this vector. Okay? So the norm of this vector is equal to the norm of this vector. But this is just a number. Do you agree? Because A, B, and C are these numbers that you can read from your plane. X node, Y node, and Z node are these numbers. So that's just a number. So I can give the role of lambda to this one. And then do you remember, if I have norm of lambda multiplied by my vector, what I'm supposed to do? I have to take the absolute value of the number, I have to take the norm of the vector, and then multiply it. Yes, that's the same story here. So this becomes the absolute value of this lambda. And if you don't mind, let me write it in order. Okay? Do I need absolute value for the denominator? No, because the denominator is always non-negative. Yes? But multiplied by the norm of my vector. The norm of this vector is the square root of A squared plus B squared plus C squared. Yes? And we can simplify this. A squared plus B squared plus C squared is this number multiplied by itself. So one of them and one of them will be cancelled. And finally you get a very nice formula, easy to memorize. Yes. The reason that this is easy to memorize, this is just an equation for the plane, but you have changed x to x node, y to y node, z to z node, yes? And then the denominator is square root of the coefficients squared. So that's a nice and compact formula whenever you want to find the distance of a point to a plane. The only thing that you have to be careful, if you want to use the formula, you have to move everything to the left. On the right hand side should be 0. For example, in this case, I have already done that. So let us use this formula. So what this formula tells me is that I will have a square root of this number squared, this number squared, this number squared, 4 plus 0 plus 1. And in the numerator, instead of x, I put the x of my point becomes 4. I have an absolute value on top. Instead of z, I put minus 5. And instead of d, I just put d. And if I calculate this, is minus 19 is minus 15, but the absolute value is 15 divided by square root of 5. So that's the answer that we get. But do you believe that this answer is correct? So what was the answer? The answer is supposed to be 3 square roots of 5. But the one that we get is here. Is that right or not? Is 15 divided by square root of 5 that number? Yes, that is the same number. Why? Because I told you this is a trick. And this is important to know. Whenever you have this and you want to get rid of the square root sign in the denominator, you rescale it by the same number. Then what happens? It becomes 15 square root of 5, but the square root of 5 times square root of 5 is 5, and 15 and 5 are simplified, so you get the same number. Yes? Okay. Okay, so since you have the formula here in front of you, let me just give you another example way for you to solve it, okay? Of course, even if you don't have this formula, you have to start from scratch. But starting from scratch for a problem that finding the distance is not the target is actually distraction a little bit. So, okay, so first let me give you a very simple example, two examples, and I will wait for you. We have enough time. So, if we will finish it tomorrow. So, a simple problem. Determine M so that the distance from the point A equals to, let me just use these numbers, from the distance from the point to the plane, P with this equation, 2x minus y plus 3z minus m equals to 0, B is the square root of 14. Length units. Okay, so I think it's better in this problem to use the formula.
Okay.
Is the problem clear? Okay, I'll give you 2 minutes. I want to see that if you can finish it in 2 minutes. Yes?
Yeah.
Finished. No answers? No?
One more minute and I have an answer.
2 more minutes. I repeat it. Yeah, just read your answers.
M is equal to 2.
No? Continue.
I got m is equal to -2.
Partially correct. Probably you didn't care about absolute value.
Yeah.
Does it have 2 answers?
Yeah.
Yeah. One of them is -2.
Yes.
The other one is 26.
Yes. Finished. The problem is finished here. Thank you. So it is nearly 3 minutes. And that's good. So let me. Yes. So what we are supposed to do, the formula is in front of you. Yes. The distance from this to this should be square root of 14. And I have given you everything standard. So what you need to write, the distance formula is equal to square root of 14. Yes. So what you need to do, what are the numbers here? A squared, B squared, C squared, they are components of the normal vector. So it is 4, 1, and 9. And then instead of x, y, and z, you put these numbers. That's on the board. So this becomes 4 minus 1 plus 9 minus n. Yes? And then I have given you this number to be 14. Square root of 14 times square root of 14 is just 14. And then it's equal to what? 13, 12, yes? But absolute value is this. There are two options. So 12 minus m is either 14 or negative 14. If this is the case, m is -2. If that's the case, m is what? 26. So it would be probably under 1 minute, yes? So you can do it, but you need to appreciate that you have to do it fast. Is that understandable? Okay, let me give you another challenge, okay? You need to find a way to enjoy. So, okay, so let us do this. Don't start solving when I'm writing, okay? Because now it's a competition. So, I want to write it short. I give you 2 planes. I write it in a way that you cannot start immediately. Ah, by the way, do you have the formula? I erased that. Do you have it in your memory now?
Yes.
Yes or no?
Yes.
No, so it's working, you know? So, I will give you 2 planes. Okay, x plus 2y minus z equals to 0. I give you another plane, call it p prime, with this. I want to exactly write this because if you read the answer, I want to check it against mine. Okay, so I give you 2 planes, this one and that one. Okay? The question is that determine a point on the y-axis or you can talk about me the or a, okay? A point on the y-axis equidistant from P and P prime. Yes? Okay, I can set it for 2 minutes, I think. Ready? Yes. So I start. Repeat? Okay, I repeat. No answers? I repeat. Yes?
I think I have an answer.
Yes.
0, 20, and 5. So the point, that's the coordinates of the point.
0?
20 and 5.
No, it should be on the y-axis.
Oh,
Yes?
I don't know if it's the simplest possible form.
Yes?
Square root of 50 divided, the y coordinate is
Yes?
square root of 50 divided by square root of 32.
No.
Så massa random svar.
Yeah.
Yes?
5.
Not complete. One answer is correct. So Ruben, you did it in 5 minutes, yes? With one answer. Yes?
5 over 3.
Yes. Thank you. So it was 6 minutes approximately. Yes, but that's good. I think, so let me just see if I want to solve this. So what do you see? Determine, I don't know, because first of all, this is an example that we have studied today, so it shouldn't be very hard to realize that there is a connection between this and this problem that I talked about, yes? So a point or the point or points, I don't know, that after you solve it is points, yes? On the y-axis, yes? Equidistant from these two. When you say that I am looking for a point on the y-axis, I immediately write something like this for myself. That is the point, yes? And the distance from this point to that plane, I just don't write too much, you know? This is 1, 4, 1. If you want, I can write it for you, yes? But then instead of x, I put 0, instead of y, I put beta, and there is an absolute value here, so this becomes 2 beta. Agree? Yes or no? Instead of x, I put 0, instead of y, I put beta, instead of z, I put 0. Look at this. This is the distance from that point to this plane. Yes or no? Okay. And then the distance from this point to that point should be the same distance. So square root of 1 plus 1 plus 4. Yes? And then you put this one 0, y beta, z plus 5. You see, it doesn't take that much actually. And then I have to design the numbers so that they are cancelled. Yes? And then 2 beta is this one. So there are two options. 2 beta is to absolute values are equal. Either the numbers are equal, so beta is 5, or one of them is negative of the other one, which is negative 5 plus beta. I move this to the other side, it becomes 3 beta is equal to minus 5. So beta is minus 5 over 3. Is that your answer you told me?
I think I said 5 instead of minus 5.
What? So I have done a mistake somewhere.
No, I might have made a mistake.
Okay, I think mine is correct. You see, I think it is under 1 minute, isn't it? So this is good if you care also about the speed. Because if you care about the speed, you start respecting your memory. Because memory is really handy there, yes? So it's very good actually, we solve some of the, of course this is not the answer, but if you want to provide the answer, what you should provide, you should say that 0, 5 and 0, 0 and minus 5 over 3 and 0, yes?
Så jag gjorde det så här. Det skulle ha mer snabba.
Is that understandable? So I think that's a good exercise. Sometimes we work on the speed as well, because these are really, you are good in these calculators. You should be. These are not hard things for you, okay? Thank you. So we meet in a few minutes. No questions? Okay. But before, we have 2 minutes. Before moving, could you anticipate there are 2 answers for this problem? I haven't talked about this. Can you tell me what is the role of this number in this equation? If I have this, if I keep A, B, and C fixed, and I start changing D, this plane will start changing. But how? Do you know how? Will it rotate? Will it be translated? Exactly like, do you remember when I told you that in Math 2C, if I change K, the slope is changed, and I change M and keep K fixed, it will go up and down. Yes? So that is the same thing I'm asking about the plane. Let us keep A, B, and C fixed, and I start changing D. What happens to my plane and why? Yes?
It is transferred or?
Yeah, it will be parallel to the previous ones. Why?
Because A, B, and C are multiples of the equation.
No, I'm keeping A, B, and C fixed. So it means the normal vector of all those planes will be the same vector. Yes? Because A, B, and C are supposed to remain fixed, I am changing D, so I am not changing A, B, and C, so a normal vector A, B, and C will remain normal to all of them. And if it is supposed to remain normal for all of them, they have to be perpendicular to that, they have to be parallel to themselves. Okay, so could you anticipate based on this that there are 2 solutions for this problem? Because you have a point fixed here, so you have a point fixed, you want to find M so that the distance from this point to the plane becomes a particular number, yes? And it is clear, you have one of the planes here, and the other plane would be the same distance above. So these two should be, there should be 2 answers. But predicting that there should be 2 answers here needs more imagination. And I would recommend you try to understand this also from geometrical point of view, that there should be 2 answers, not 1. Okay? Thank you.